So what we're going to do today is talk about systems of equations. In the past, we've done linear systems of equations. Today, we're going to do linear quadratic systems. Essentially, all that means is you've got a linear system and a quadratic system, or you're looking for where do the graph of a line and the graph of a parabola, where do they intersect? So the solution for linear quadratic might consist of 2 points of intersection, 1 point of intersection, or really no points of intersection. So when we graph our systems, we really, for the most part, are only going to be graphing systems whose solutions have 2 points of intersection. Okay, so essentially it's kind of like something like this. You would draw a parabola, you draw a line, and there's your 2 points of intersection. There's a chance that it would happen where you drew a parabola and you drew a line and the line just touched the parabola once. That would be your 1 point. And you might have an example, I'll just go upside down here, where there's your parabola, there's your line, and they never actually intersect. So my guess is on the Regents exam, they're going to probably, if they give you one of these, which they have been known to do in the past, it's probably going to be one that's got 2 points of intersection. When you saw the linear and quadratic pair graphically, when you graph both of them, so you're going to draw the graphs of both equations on the same coordinate plane. When graphing the quadratic, you're going to show your table of values. You can do it all on the calculator, and you're going to make sure that you center that around your vertex. You're going to find the common solutions. You're going to find the points of intersections by reading those points of intersections of the two graphs. You might want to look at the calculator's table of values to verify that the 2 points you think are the solutions really in fact are. You might want to look at or do something called the second trace intersect, enter, enter, enter. I'm pretty sure we've done this before at some point, but you've got 2 points that you're looking for, so you better do it twice. And then no matter what, when you write your solutions are ordered pairs. So you have to write your solutions as XY ordered pairs. So the first thing you're going to do is you're going to find this, well, the first thing you're going to do for finding the solution set for this example is you're going to have to graph both pieces. I'm going to go for the line first. Okay, that's much easier for me to graph. So y equals mx plus b. My y-intercept is 3. So I begin at 3 on the y-axis. My slope is -1. So I'm going to go down one to the right one a couple of times. Going down to the right, it's the same thing as going up and to the left. And I'm going to create my line here. With the quadratic, I'm going to do this all on the calculator. It just makes a lot more sense. So I'm going to have my table of values. I'm going to go to my calculator, which I don't have pulled up, but take a minute. Alrighty. Just going to do a quick clear RAM. So I'm going to do second plus 7, enter 2. So whatever's all set up there, I'm just going to get rid of it. So I'm going to go into y equals, and I'm going to type in the quadratic, the parabola. It's x to the second, and then it's minus 2x plus 1. And I'm going to take a look at the graph. So I notice that my turning point, my vertex, looks like it's actually on the x-axis. It looks like it's somewhere over here. So I'm going to go to my table of values, and I'm going to see if I can find that 1, 0 point. And that's exactly what the vertex looks like it is. So if I can line up my top and my bottom y values, and I just grab the middle 5, if I can just grab these middle 5, where my y's and my y's 4 to 4 are the same, 1 to the 1 is the same, and then here's my vertex. I'm going to create that table on my paper. That's not it. There we go. So the table of values I'm creating would be -1, 4, 0, 1, 1, 0. That's my vertex. 2, 1, 3, 4. And that's what I'm going to graph. So -1, 4, that looks like a point of intersection for sure. 0, 1, 1, 0, 2, 1, that looks like a point of intersection for sure. And then 3, 4. And then I'm going to draw my parabola. So the idea is I have to state the points of intersection. I'm pretty sure it's the ones that we thought that they were. I'm pretty sure the first one is going to be this point -1, 4, and the second point is going to be 2, 1. But to be certain, because I don't want to make a mistake, remember I'm doing this graph by hand, I'm not doing it on the calculator, I want to go back to the calculator. And so what you should be doing is just kind of confirming that the points that you think are correct really in fact are. Go back to y equals, don't get rid of your parabola, go into y2, and say, let's type in the line y equals -x plus 3. Take a look at the graph. There are 2 points of intersection. We kind of had an idea of what we thought that they were. I'm going to go to my table of values. I find it a little bit easier to do it this way first. Notice at -1, both y values are 4. That happens to be this ordered pair right here, and we thought that that was a definite point of intersection. The other point that we thought was a point of intersection was, I think, was over 2 or 3 or something along those lines. But as long as I can find where my y values are the same, 1 and 1, the x value was 2. So your solutions then are 2, 1 and -1, 4. The instructions that are on the calculator were this. We basically said if you go back to your table, if you go back to your notes for a second and you look at this thing right here, highlight. So you might want to check the solutions on the calculator by doing second trace intersect, enter cubed. What that really means is once I have these two equations in my line, I can go to second trace, which is calculate. I can go down to choice 5, which is intersect. Once I hit enter and it asks me for first curve, basically is y1 that top left-hand corner my parabola, and it is y2 that top left-hand corner my line, it is. Should I guess the point of intersection? Absolutely, and there it is. Same answer that we got right here. If I were to do it again, I would go second, trace, intersect, choice 5, but before I hit enter 3 times, I'm going to use my arrow pad to move my cursor away from the first point. So when I hit enter 3 times, it defaults to the second point of intersection, which is in fact 2, 1. Okay, so most of it's really done on the calculator. You're centering it around your table of values. And then for your solutions, you're going to write, and I'll put this in a different color. So my solution, you don't even have to write that word, but solutions are going to be -1, 4, and remember there's 2 points, and 2, 1. Okay, so that's the graphic approach. If you want to do it the algebraic approach, and they might ask you to do one or the other, or they might have you choose, but if you want to do it the algebraic approach, you go back to systems that we did a while ago where we talked about using the substitution method. And that's the only method that we're going to use if it's algebraically. So you're going to solve one of the equations for one of the variables. Usually you end up solving one of the equations for y equals. That's what you usually end up solving it for. Whatever you do, once you get one of the equations for y equals, you're going to substitute that equation into the other. You're going to set the equation equal to 0. You're going to factor, and then you're going to solve. Okay, that's nothing new. Set the equation equal to 0, factor, and solve. Once you get that, you've got two values for x. So you've got the beginning of your ordered pairs. Solve for the other variable, solve for the y, by substituting the values into either equation. You have to do that whole process twice since there are in fact two solutions. Okay, so I can take a look at what's happening on this particular problem and I can say, well, they're both solved for y equals. That's nice. I'm going to take what y equals from the first equation and dump it in for the y in the second equation, which means I'm going to say x squared plus x minus 4 is equal to 2x minus 2. Well, we want to get the equation equal to 0. So if I want to get this equation equal to 0 and my quadratic x squared is on the left, then I just need to subtract 2x from the right, bring it to the left. I need to add 2 from the right, bring it to the left. Now I've got the 0 all on the left, right, because 2x minus 2x is 0, negative 2 plus 2, remember those are additive inverses. And on the left-hand side, combining like terms, x squared minus 1x minus 2 is equal to 0. Factor it. It's an IM. I need to think of what two numbers are going to multiply to equal -2. At the same time, what two numbers are going to add to equal -1? I know that's going to be, in this case, a -2 and a +1. So I factor this by IM, x plus 2, x minus 1, sorry, x minus 2, x plus 1 equals 0. Drop my wall. Take each factor out of the parentheses, set it equal to 0, and solve. Okay, so I've got the beginning of my two ordered pair solutions. My first solution is going to be 2 comma something. That's my first x value. My second solution is 1 comma something. Well, you've got two equations which you can use to test your points. I'm going to use this equation right here. Basically, it says y equals 2 times x minus 2. Well, if x is 2 the first time around, then I get y equals 4 minus 2, or y equals 2. So when x is 2, y is 2. If I use that same equation and I test the ordered pair x value of -1 and I do the math, then y equals -2 minus 2, or y equals -4. So these are the two solutions shown algebraically, 2 comma 2 and -1 comma -4. Okay, let's do one more of those examples. Last one that we're going to do, and then you get started on your homework. You already have one of the equations solved for y equals, so I'm going to take what the y equals, I'm going to dump it in for the y, which means x squared plus 2x plus 1 minus 5 equals 2x. Well, essentially right now on the left-hand side, I can kind of combine like terms. I've got these guys right now. So I could say x squared plus 2x minus 4 equals 2x. So set the equation equal to 0. Subtract 2x from both sides. Now I've got 0 on the right, but on the left, I've got x squared. That happens to cancel, minus 4. This is one of those dots problems. So this becomes x minus 2, x plus 2 equal to 0. Drop the wall. X minus 2 equal to 0. In this case, the x value is positive 2. X plus 2 equals 0. Solve for x, and x is -2. So we've got the beginning of our solutions, right? So the solutions are going to be 2 comma something and -2 comma something. Well, I'm going to go for this equation again. It looks a little bit easier. So y minus 5 equals 2 times x. When the first x value was 2, you get y minus 5 equals 4. Well, add 5, y equals 9. So when x is 2, y is 9. If we do it again, and we say y minus 5 equals 2 times x, and this time x is -2, this becomes y minus 5 equals -4. Add 5, y equals 1. So when x is -2, y is -1. Okay, so that's it. You're basically solving a quadratic in a linear system by graphing or algebraically. Regents will tell you what they want to do. If they tell you it's optional, you do whatever you like best. Good